Good morning and welcome to our webinar on smart and V2X-ready corporate fleets that we've entitled Making EVs Work Over Time. Throughout the next hour or 1.5, let's see how long we need, we'll guide you through our latest position paper that we've published on the issue. And then we have a panel with some of our members that have contributed case studies to the paper, and we'll discuss a bit in depth these like real world deployments with the experts that make things happen on the ground. So looking forward to spending that next hour, 1.5 with you. So yeah, as I said, this is kind of the structure, right? We'll have some opening remarks. My name is Thomas Neumann. I'll be guiding you through debate today as our moderator. I will be presenting very briefly our position paper. Then we'll go into our case study with our panelists. They will all give brief input presentations. We'll then have a Q&A. Including Q&A on Slido, where you can ask your own questions. We want to keep this interactive if we can, and then we'll close things off. So yeah, housekeeping remarks. The chat is open in case you have technical issues, these kinds of things. If you have questions, please ask them on Slido so we can make our selection. I have colleagues here in the background having a look at the Slido, and the QR code will be displayed also throughout the slides later, so you can still open it then. But yeah, feel free as the questions pop up as we go along to drop them in the Slido, and we will take them on at the end of the webinar. Very much encourage you to do that. So why are we here today? Well, corporate fleets. As you may know, the Commission is considering preparing a legislative proposal on corporate fleets, and there's many good reasons to tackle the decarbonization of corporate fleets as a priority. First of all, they have a large oversized sales share, right? So often when we think about cars being sold, we think about private consumers, households buying cars, but actually the majority of cars being bought or leased today is for corporate actors. 60% of vehicles in the EU are sold to corporations. So it's a big part of the market, and so it has a very big outsized decarbonization impact. Secondly, often these cars have a higher daily mileage compared to private drivers. They are used more consistently throughout the day, not just for a short commute, but they're really accumulating a lot of kilometers. And so not only do they account for a lot of sales, but they also drive more kilometers. So again, outsized decarbonization impact on that side. Thirdly, they have a high turnover. Corporations usually acquire their fleets for about 36 to 48 months, so 3 to 4 years. And then they go to the second-hand market, where that can lead to more affordable zero-emission vehicles on the second-hand market for private consumers. And then lastly, and that is what we're going to focus on today, they are a prime use case for smart and bidirectional charging and for grid integration. And why that is the case, we'll go into now. Because in our opinion as smartEn, we think that grid integration of corporate fleets is a win-win solution, and a lot of actors can actually profit from this, right? I mean, first of all, obviously, local grids could be stabilized. So grid integrated vehicles can help solve grid congestion and can therefore defer grid reinforcement needs and costly investments. So, that is a win for system operators, for public purses, for subsidies, and for system stability. But also fleet operators, so actually the ones buying the vehicles, can profit tremendously, because obviously when you charge energy at a time when it is cheap, or when you even manage to sell some energy back to the grid at opportune times with V2X solutions, you can generate economic benefits and market-based remuneration. And therefore, it is possible to cut operating cost and TCO, and especially for fleet operators that maybe don't have the same motives as private consumers, right? There's not as much, let's say, brand loyalty involved, but it's a very economic, rational decision. These kind of TCO considerations might weigh quite heavily. Then also for flexibility service providers, for aggregators, etc. These are a prime use case because fleet vehicles often follow predictable driving patterns. So you can kind of predict where they will be at any given time of the day, making it easier to optimize your charging patterns compared to private consumers. And they often park in centralized locations. So you have kind of one location you need to outfit with, the right equipment, the right IT infrastructure, etc. And you have instant scale and instant planability when you don't work from individual customers' vehicles, but like from bigger fleets. We also think that there is an industrial advantage to be gained here, right? Because obviously this is a nascent new ecosystem, especially when it comes to V2X, but it has major long-term potential. And if Europe is the first continent to develop these solutions at scale, then we could gain an innovation and industrial advantage, being the ones that scale this technology and sell it globally. And that could be a lever corporate fleets to achieve this kind of industrial advantage. Also, when you start with corporate vehicles, there may be a shop window effect, an educational effect, because consumers that maybe drive for their job a corporate vehicle and so get acquainted to smart bidirectional charging might be more likely to actually deploy that in their own private life, to be more open to these solutions. And so they might be more likely to adopt them and reap the economic benefits. So there's a consumer benefit and scaling benefit and a mentality education kind of benefit there as well. And lastly, the economic gains that we mentioned earlier, they may help reduce the need for state support in the EV transition. I mean, obviously right now we're talking about a lot of strained public budgets, especially at EU level. There's bitter fights about the budget and where to allocate our scarce resources. If we improve the business case for zero-emission vehicles for the transition, and smart and bidirectional charging can be a lever for that, then there might not be as much need to supplement that with public subsidies. So we think it's a win-win-win for basically anyone involved, and it's a kind of no-brainer that the Commission's initiative on corporate fleets, plus the Commission's just ongoing work on other files, should pick this issue up. How do we enable that? Well, these are some of our policy asks. So in the context of this upcoming proposal, promote the uptake of smart and bidirectional charging, including through improved consumer information, make people aware of the benefits, make fleet managers aware of the benefits of smart and bidirectional charging, and encourage companies specifically to conduct an analysis on the cost and benefits of this, because many companies might not yet be aware that they can actually gain from this. So just encouraging them, not an obligation, but making sure that they are aware of this and are encouraged to conduct an evaluation what they could gain, could lead them to actually discover what benefits smart and bidirectional charging can offer. Tackle regulatory barriers to smart and V2X technologies, both at EU level, right? So here we're talking about grid and network codes, communication protocols, double taxation, energy taxation directive, of course, still stuck for the moment, but these kinds of obstacles. But also in member states, we have the regulatory sandbox on V2X coming up from the Commission side. But generally, for smart and bidirectional charging, there can be all kinds of barriers at national level, from national taxation systems, lack of dynamic tariffs, etc. So member states should assess whether there are any barriers to EV adoption, specifically in corporate fleets, and to smart charging, and should tackle them where they can. Then there should be full interoperability and open markets, of course, so consumers can freely choose their car and aggregator and supplier, so that we have a healthy competition and consumers can reap the full benefit, and fleet operators. And lastly, there should be a look at type approval to see whether any technical changes to vehicles are needed, so that V2X capabilities are ensured going forward. I mean, for now, obviously, smart charging is there, but in the next step, we should look at the next frontier, improved V2X capabilities of vehicles. So these are some of our policy recommendations from this paper, which is now available on our website for you to download. And with that, and that's a little intro about the relevance, we will now move to our panel with a series of small input presentations. And first of all, we have Laura Casolo, who is R&D Program Manager at Hive Power. Laura, thanks for joining us. Very much looking forward to your remarks. And yeah, feel free to tell us a bit more about your case.
Cool, thanks, Thomas. And welcome to everybody to this webinar. And just a few words about who's Hive Power. Hive Power is a Swiss software company specialized in flexibility optimization. So we enable businesses to be able to charge at the best time, best price, with a seamless user experience, to unlock also new business models when it comes to having the energy world connecting to the mobility space. So if we look at our product, we have our platform, which is called Flexo, which combines advanced algorithms, real-time data, and in integration with existing infrastructure at the customer sites to provide value stacking across different use cases. So coming from time of use, optimization, but up to peak shaving, local congestion management, and ancillary services in like AFRR and MFRR. So today I will present our use cases with AMAG. AMAG is Switzerland's largest car importer and dealership and a leader in fleet electrification. So how the AMAG case was born is that with the rise of electric vehicles in their operations, AMAG thought solutions to reduce charging costs, integrate renewable energy, and generate new revenues across flexibility services. And this all without impacting drivers' experience. Because you mentioned it before, Thomas, and I mean, the user side is really important because the less the impact the user feels, the better it is, and the better is the acceptance on this new optimization around smart charging and flexibility. So what Hive Power does with AMAG is that we enable our platform to manage their distributed fleet using smart charging algorithms. So we have grid balancing logics with plus and minus flexibility, so that when, for example, when demand on the grid is too high, charging can be interrupted, but also another case is when solar generation peaks and there's a risk of curtailment from the solar case, charging can ramp up to absorb the excess. And we play around with these two. If we look at ancillary services, we have MFRR and the IFRR, where we have it through EVs on the first one and through the HEMS side with home energy management systems on the other. And the main difference is around like the reaction time that we have for these two ancillary services. So the case and the success of this project with AMAG also comes from really strong synergies across the value chain from the end-to-end perspective here. Because from one side we have AMAG, who's the car importer and dealership, so they are the fleet owner and operator with a real commitment to electrification. Then we have AutoSense providing fleet management tools and intelligent charging, which has as a module all the optimization algorithm coming from us, from Hive Power, where we act as a technical aggregator and virtual power plant orchestrator. On the other side, we need another player in this value chain to be able to enter the energy markets, and that's the role of the BSP, which is covered by Axpo in this case as the biggest energy company in Switzerland. So what this case demonstrates is that this strong partnership across the value chains are really fundamental to be able to unlock these new businesses where vehicles are not serving just the mobility side, but also the energy side. And this brings benefits up to hundreds of euros, which go even higher when it comes to light-duty vehicles, for example, where we have slightly bigger batteries and higher capacity also to be traded on the energy market side. So I think it's our favorite case here because it's the most advanced one. It's really able, our blueprint also for scaling in other countries, and it's real bundling of the role of partnership, technology, and also this really push from the regulatory perspective also to enable new business model, which now are running on V1G, but soon also on V2G. And on this side, I think from the technical perspective, we're ready for V2G. There's nothing that is missing, but it's just up to the regulatory side and to unlock. But as you have seen also in these days, there are a lot of new propositions ramping up in the market with a lot of announcements around V2G. So, I mean, this moment is not so far in time. So really looking forward to it. Thanks a lot.
Thank you, Laura. And yeah, inspiring case study. Very nice to see the collaboration across different parts of the ecosystem, different stakeholders, and also nice to hear that V2G is maybe not so far off if we get the regulation right. I guess that's a nice task for us as smartEn to engage on in the coming months and years. So yeah, thank you. We're going to move now to our second panelist, and we have Davide Michino, who is head of global product development and energy at Enel X, and also the chair of our e-mobility task force. So Davide, thanks for joining us, and the floor is yours to present your case study.
Thank you very much, Thomas, and also thank you to invite Enel to expose some case studies. So first slide I will move. So just I don't want to speak about the Enel. I think that majority of you know the role of Enel worldwide, but I just bring a slide to show to you our role as an aggregator worldwide. So we have almost 10 gigawatt of flexible power under management. Majority of these are on explicit services, but there are also some cases when we enable implicit flexibility and helps the customer to save money on the bill directly with optimization. I bring today not the most advanced case study from our side, but the one that is very simple and is also very practical to implement, and where the fleet can also use to reduce significantly the TCO, but not of the electrification of fleet, but also to speed up the electrification of fleet. So I bring this success story in Italy, where we help one of the main logistical player in Italy to electrify the fleet and reduce the TCO, not with the super fancy, I would say, explicit services, but with very practical implicit flexibility solution regarding load management, because this customer have different problems in terms of electrification for limitation of the grid connection, but also because you want to avoid any switch to a medium voltage connection. So we help to install more than 3,000 chargers in more than 50 sites, and enable with the simple cloud logic, advanced load balancing logics. I bring this case study not because it's I would say a market standard technology, load balancing, but I still see very small implementation of this in terms of fleet. Why there is a huge value for capex reduction, but also opex reduction in terms of demand charge. When in specific country, demand charge is I would say significantly. So reducing the power that you can absorb from the grid is very effective on the electrification cost. The complexity of this, I would say, I add here. One is that we need to manage also dummy charger, because this customer have a 3-wheel vehicles that don't use any standards in terms of like type 2 plugs or communication standards. So it's very dummy plugs. And so we needed to adapt our advanced logic to also take care to this simple dummy charger. And second challenge, you need to imagine that this is up and running since 4 years. At the beginning, we had a lot of problem with the vehicles that doesn't support smart charging, also because sometimes it's the first series of the vehicle, and the board charging software sometimes have bugs or that doesn't support standby or strange and fast power reduction. This is the key challenge that we find that we solve together with our customer, but also talking with the OEMs. And I think this is one of the role that as Enel mobility we had in the past, to also test interoperability between the charger and the vehicle, especially in the smart charging space. So that's what I bring today, because it's a simple things that is available. We don't need to wait market changes. We don't need explicit flexibility unlocked. It's a value that is available. Every passenger vehicle can access to this, and this speed up a lot the electrification of the fleet. Thank you.
Thank you, Davide, and good to know that we have these solutions kind of already ready to deploy without needing to wait for regulation. That is, I think, nice key message to take away already from today. With that, without further ado, we'll move straight on to our third panelist of the day, which is Claire Weiller, Vice President of Product Development, Program Management at Fermata Energy, Nuvve. So Claire, thanks for joining us, and passing the floor to you.
Yeah, hi, good morning. Thank you for having us to present our case study. So as Thomas said, I'm leading product management at Fermata Energy, which is now part of Nuvve. And in this short presentation today, I'll focus on Nuvve's deployments with corporate fleets in Denmark, where we have been, sorry, next slide. Oh, sorry, yeah. Where we've been participating in frequency containment reserve markets with V2G, so bidirectional EV chargers and light-duty vehicles for over 8 years. I'll briefly go over a bit of company background, a summary of V2G operating results that we have from this experience with the Danish corporate fleets, and then zoom in a bit on the benefits of V2G from the fleet operator's perspective. A bit of background about Nuvve. It's a US headquartered company whose core mission is turning electric vehicles into dynamic grid resources. Our V2X software platform and solution unlocks two-way power flows between the EVs and the grid or the local building and the home by applying machine learning to generate intelligent forecasts and optimization plans that deliver economic value while protecting battery health and the drivability of the vehicles. So with this, Nuvve helps corporate fleets customers unlock flexibility from their EVs, enhancing reliability, accelerating electrification plans, and lowering costs for them. So getting into the Danish case study, we have been operating V2X at a number of corporate and public sector fleets, including municipal and utility fleets for over 8 years. You see a few statistics here. These fleets really benefit from lower costs of electrifications and a fully managed charging service, as you'll see, thanks to the additional revenue that is coming from supporting the grid through frequency regulation. And a key maybe operating result to note is this. On average, each vehicle that participated in the market earned about over 1,800 euros, so 1,800 euros per year, on average per year over the last 8 years. So this is pretty consistent, good, a good historical period of data to have. And we're seeing that these are relatively small batteries. They're Nissan Leafs, ENV 200s, like commercial vans. And we really see that this level of income from a vehicle while it's parked is what will attract more fleet operators to adopt V2X and enter the market with this technology. So, and we're working, of course, through smartEn and with other institutions to make sure that these ancillary service markets are open, accessible, and fair across Europe for distributed energy resources like these fleets. In the white paper, in the smartEn white paper, we presented the specific case of the municipality of Bornholm in Denmark. Here, you have a few stats about the rollouts, but the context is particularly appropriate for V2X. Bornholm is an island. The municipality has a fleet of 21 electric vehicles that are usually traveling on the road between 8 a.m. And 4 p.m. They can drive up to 200 kilometers per day. However, they do often come back with a pretty high state of charge still. And they're then participating in the frequency response markets for around 17 hours per day. Sorry. So the vehicle fleet patterns are adequate for V2X. And also Bornholm is an area of Denmark that has a very high penetration of variable renewable energy and that needs really a lot of stabilization services for frequency. So we're aggregating these vehicles from this municipality with other corporate fleets that we have in the rest of Denmark in a virtual power plant that provides these market services for FCRN. And our forecasting algorithms work to predict when the vehicles are going to be available, so how much total capacity we have over the next day. We model the prices and bid in the markets, and basically this is where the value is coming from. So At the same time, from the user's perspective, we ensure that the vehicles are ready to go when they need to be for the next morning's duties. And that's a key, of course, part of the service. So we're both maximizing the revenue potential, but also helping the customer with their operations. And so that's the sort of last maybe key point here, is that from the fleet's perspective, doing V2X looks a lot like business as usual in operating their fleets. But on top of that, they have some additional benefits. So we are able to deliver a kind of all-inclusive managed charging package, thanks to the additional grid service revenues. So it includes the charger hardware upfront, maintenance, software, remote monitoring, and energy for the vehicles for the fleet. And this is all at sort of attractive costs that are lowered because of the additional revenue stream. In addition to visibility on the costs and the sort of flat fee structure, which is good, we're really giving them visibility through a data portal and dashboard on their fleet activities, and giving them the guarantee that their vehicles will be ready outside of the grid service operations for when they need them. So it's really peace of mind that's brought to them through Nuvve, keeping this charging infrastructure fully managed and operating bidirectionally. So that is, that's it for me for today. So thanks for listening to the case.
Thanks, Claire. Indeed, very interesting case, both showing that V2X is already the reality in places, and also showing, of course, the importance of putting the user first and the fleet operator first, and making sure there's a convenient package for them and not too much of a headache. So thanks for that, and we'll dive back into it later with some more questions. But for the moment, I'll bring it to our last panelist of the day with his input presentation, which is Quentin Maitre, Chief Marketing Strategy and Development Officer at Hive, which is part of the EDF Group. So Quentin, thanks for joining us, and yes.
Hello, Thomas. Hello, everyone. Thank you for the invitation. I do not present EDF, but maybe Hive, which is basically the technical aggregator and V1G and V2G operator within the EDF Group, and mostly active in France, the UK, a little bit in Belgium. And so today the goal is to present a bit what we do with fleets. So one example of what we do in V1G, and one example of what we do in V2G, and the limits basically of what we do. So if we go to the next slide, it's actually our biggest use case in V1G is our own fleet. EDF is engaged into its fleet electrification for 40,000 cars to electrify by the end of the decade. So basically thousands of charging stations across France on basic power plants, offices of EDF. And so with employees, with a lot of electric cars, as you see on the picture, and charging basically, plugging in the charging station basically in the morning and leaving in the evening. And so as a utility, obviously we need to charge smartly all our employee cars. And so this is an example of what we do. We optimize regarding the mobility constraints. So the car needs to be charged at the end of the day, obviously. And we charge regarding basically the real-time electricity system conditions. So basically the spot market. And more in France and in Europe, we have very low prices in the middle of the day when you have sun and solar production. So basically what you see on the graph is that we shift the morning peak. So you see in green the electricity prices, basically the spot market with big peaks in the morning, in the evening, and low prices, very low prices in this case, up to €0 per megawatt hour in the middle of the day. In blue, that's the natural charging curve. So basically all the employees charging in the morning if you don't shift the load. And in yellow, that's the optimized load curve that we generated and that we dispatch to all the charging stations. And so we try to match the best prices and the best timing to charge all the cars. The limit of this service is that it is AC charging station, so basically 7 kilowatt AC charging stations, and you don't have access to the state of charge of the car. So in this case, so very V1G use case, which is the case for B2C and for AC charging for fleets. Basically, you ask the users what is the amount of energy they want to charge. In this case, there are thousands of users. We look at the stats and said, okay, everybody will have 20 or 30 kilowatt hour each time they plug, which corresponds to 80% of the needs that we saw from the statistics. So that's not very optimal because some of the users may want more energy. For example, the Tesla users, when their battery is very low, they want more than 30 kilowatt hours of energy. And for the optimization, as we don't really know the amount of energy to optimize, because maybe the battery needs less than 30 kilowatt hours, it's less optimal in terms of optimization and in terms of economic results. That's the example of V1G, and next example is V2G, also with fleet. So that's basically the exact same use case on Claire presented in Denmark with the same chargers and the same cars, so Nissan cars with CHAdeMO 11 kilowatt chargers in DC. So this is not a really new use case, but we have a bit of return of experience, and since they have been installed. And what you see on the graph is for car sharing pools. So very often the cars are plugged into their charging station. We set very basic rules of you can't discharge below 35% of battery, and every morning, and basically when the user needs it, the car needs at least 80% of battery. And then depending on the electricity market condition in real time, we charge and discharge. What you see at the top of the graph, the yellow curve is basically the state of charge of the car, charging and discharging depending on the prices. Once again, the limit to scale this use case is the communication protocol between the car and the charger, because here we are talking about CHAdeMO. We are working a lot on the CCS V2G technology, but what is the main problem is the communication protocol. Basically, all the car manufacturers are not using the same version of a 1511-20. And so you have to ask your charger provider to implement the different protocol of the different car manufacturer, which take a lot of time and a lot of efforts, and basically slows the progression of V2G use cases for fleets, at least on our point of view. And that's it for me.
Thank you very much, Quentin. And with that, we can move on to our panel discussion. I would encourage you still to ask your questions in the audience, questions in the Slido. At the bottom right, you have the QR code. So this is your chance, now that we've heard all the presentations, to dive deeper and to clarify any questions that you may still have. And with that, maybe we'll start with some of the questions we've prepared from our side. And maybe let's start a bit with the technical hurdles and challenges in the scalability, and then move on in a second block a bit to user experience, which is of course key to making this work. And I'll maybe come back first to Laura. Laura, how transferable is your solution? And feel free, by the way, other speakers to then jump in, because that's actually interesting for all the use cases. But how transferable is your solution in other member states? Because right now we obviously have different energy market structures in different in different geographies of Europe. So how much do you actually need to adapt your solutions when you, let's say, expand to a different market and we're trying to replicate this?
Yeah, I mean, if I look at the technical layer of the aggregation side, this is fully replicable because being hardware agnostic, both from the IoT integration side, but also from a BSP connection side, this is bringing us to integrate to whatever like EV control or CPMS we might find in different solutions. So that's typically the approach that we have with our B2B customers, independently of the country. Of course, looking at different countries, there could be some differences in the value stacking, where in some countries, time of use optimization is still let's say the value stream, which is bringing most of the value. And in some others, we can be even more aggressive when it comes to ancillary services, but also local congestion topics. So this is something also quite emerging also in Italy, which is not known to be on the forefront of this flexibility topics. But still, there's a lot to exploit also when it comes to stacking these different values. So I would say like replicability is it's really easy, I would say, if we look from this side. Of course, we need to adapt to all the regulatory aspects, which may be different in the countries, but also it might be also different concerns also coming from the O&M side. So also looking at the question from Paolo in the chat, I mean, it's likely that O&Ms would put some limits maybe on the usage of V1G, V2G, but we can still adapt it accordingly and also bring proofs on how this can evolve in the different markets. But that's where we're observing also with different cases, different projects, which are really similar to the AMA case. So that's quite promising.
Thank you, Laura. And maybe Davide, for you also the very similar question, but it's actually interesting in particular that your solution obviously works even with dumb chargers, that you don't need like hardware upgrades, so very much a software first approach. Is that something you think is replicable across the EU? And just more generally, what are the kind of main hurdles you still see to scaling your approach across different geographies?
I would say very replicable and very, I would say, market standard. So we are not the only one that can deliver this solution. Okay, we deliver in a very wide environment because the customer is big, but it's very replicable, and some players are already doing creating a lot of value of that. Obviously, the savings that you can unlock on that depends on the demand charge regulation, no? On how the demand charge work in the country. Demand charge and also the request for connection from the DSO, no? Because that depends on the switch from low voltage to medium voltage. So if you merge and connect this puzzle, country by country, the situation is a little bit different. There are some countries where the demand charge is high, is very high, or where it is time of use, like in Spain, where the demand charge for B2B customers are very complex because change every month and change hour inside the months and the day. So it's very advanced. It's obviously automatic solution that an aggregator, or we call an energy service provider, can do, unlock a lot of savings. So say yes, that's in a nutshell.
Thank you. Quentin, maybe since you presented two case studies, where do you see still the regulatory challenges and hurdles? I guess you already mentioned ISO 15118-20, but where do you see those, and how do they compare also between your two different use cases? Are the same main hurdles there, or do you see differences there?
Yeah, for V1G, definitely the main barrier is the communication protocol for AC charger. Just for instance, for DC charger, so for instance, heavy duty fleets, electric buses, electric trucks, we don't have this problem because in DC, protocols have been implemented to have access to the state of charge for free. And the result is that we have very good results, and it's a game-changing service for the electrification, for electric trucks. For instance, in Europe, in electrification studies, you will see that very often in the hypothesis, people consider that we take 20 cents per kilowatt hour as the average cost to charge your truck at the depot. With our service, what we propose in France right now for electric trucks, it's to charge at around 10 cents per kilowatt hour, which is a game changer for truck electrification. And our customer told us we are going to buy more electric trucks because now that's profitable. Of course, with the upfront subsidies that the government is providing to buy trucks, but with this kind of service, with all the communication protocol implemented, that's really commercial and that's helping electrification in Europe. That's really the point for AC V1G. And for V2G, yeah, actually it's interoperability, especially for fleets, because at home, you buy a charger with a specific brand of car. So for instance, in the case of Renault, that's a unique charger exclusive to the Renault car. In B2C, it can work because you are just charging one car on one charger. For fleets, when you buy a charger, you will have different brands of cars, Stellantis, Mercedes, Volkswagen cars. And so you need the cars and the charger to speak the same protocol. So really, that's the big point missing. It will come, it will arrive. There are some European regulation coming to help to accelerate that. But for the moment, that's a big topic.
Thank you. Then maybe very briefly, still staying with the technical challenges before we move on to user experience. I guess for most of you that applies, but maybe I'll ask the question to Claire and to Laura. You have obviously very different sites, and it's a kind of dispersed system that you have with different fleets, different locations being aggregated. Is it a challenge to maintain coordination between these, and how do you handle that? So maybe Claire, if you want to go first, since you had the floor.
Do you mean coordination amongst different aggregated fleets in a portfolio?
Yes. Yes.
Yeah, I mean, I think that's the role of an aggregator, sort of VPP platform. So we're able both to get very granular and second by second data and access to individual vehicles and really optimize on an individual vehicle level for the specific needs of of the drivers and the fleets and when they need those vehicles. And that all kind of gets aggregated through our platform in an overall view of the forecast capacity that we can then offer. And really here it depends a lot on the rules, the market rules, just making it possible to have aggregation across sites and to pull that capacity together and bid it in the market as almost as if it was a single battery on one site. And I think we are seeing like a lot of facilitation of market access for this in some countries like the UK. I mean, this is possible in Denmark, and probably you would know best where else in Europe it is. But yeah, so that's essentially the role of working on all those different levels of optimization and forecasting.
Thank you. Yeah, indeed, nice to see the key role that an aggregator can play in bringing all these different decentralized assets together. Laura, does that correlate with your experience? Do you have anything to add on that side?
Yeah, definitely, because in the end, if we look at the assets that we can aggregate in virtual power plants, if there are like stationary batteries, we know they're always available. But when it comes to EVs, they might be there, they might not. So of course, if we look at the B2B case, this is even more predictable. Less predictable it is on the B2C side. And also, I know, I mean, we always talk about aggregation, but a key part of the like this VPP logic is also the disaggregation into the single assets, because we need to have the right queue of assets that will be able to sustain like the needs coming from the grid. So the I would say the full coordination and also scalability of the solution when it becomes so distributed comes really to the fact that there's always like a plan B, C, and D of assets that can jump in if one of the assets is not available. And this is bringing resilience also when it comes to the integration with the grid side.
Thank you. Then let's move on maybe to the segment about fleet manager consumer experience, because obviously it's very important that this is seamless and it's easily accessible. And maybe here I'll start with Quentin, because in your case study, when you read through a paper, there's you talk a bit about different patterns, weekend versus weekday patterns, etc. To which degree does the adoption of smart and bidirectional charging solutions actually require behavioral change from fleet managers? How much do they actually need to plan around the charging patterns? Is it very seamless, or is there something they need to keep in mind?
Basically, we try to make it completely seamless and not to change the behaviors. So basically, in V1G or V2G, what we ask is the same information. It's when do you need your vehicle to be charged? So very often, the typical setup is I need my vehicle to be charged at 6 a.m., 7 a.m. every weekday. That's the default setup. And that's it. We already need this information, and then our software can make V1G and V2G. The feedback on this is for most of the fleets, our optimization is invisible. And that's sometimes frustrating for us because there are plenty of engineers doing very smart stuff and a lot of engineering to provide complex V2G services to the grid. And at the end, the end user say, but really, you don't really do V2G with my car during the night, right? And so that's really invisible. You just plug your car in the evening, you have your car charged in the morning, and we do V2G. Some user experience we had, the most complex user experience we had was with employee charging during the day. So the case I presented with EDF employees, because the employees are used when they plug to a charging station, they are used that it charges immediately. And so we had to explain to the users that we are going to delay the charge later in the day. Trust us, your car will be charged in the evening. So there was a bit of explanation to the employees to help on the user experience, but that's the main pain points that we have been facing.
Thank you. And you mentioned that, I mean, it's very good to hear that usually there's no big, adjustment, and that the mobility needs, let's say, of the users aren't affected. But you also talk about the role of trust and of user response and explaining these kinds of things. Maybe I'll give you that question, Davide. How important is kind of transparency with the users, real-time feedback? So how do you get drivers involved, and how do you improve acceptance of these solutions?
It's important and very complex on B2B, because we have a two player. We have the customer, that is the fleet manager and the energy manager, but we have the user, that is the driver of the car. Even more complex if the driver of the car is not always the main user of this car. Let's talk about operative fleet, and not executive cars, etc., etc. It's very important because, as also Quentin said, you need to make the user, and so the driver. Let's talk the driver aware of what is happening, And in fact, in our services, one of the key challenges is how to notify this driver. Also because these drivers are not using a mobile app, are not authenticating via mobile app. They only connect and charge. So we, I would say, develop a campaign for the driver in terms of communication to make it aware of what is happening when he connects the vehicle. There is some LED on the charger when it goes in standby, etc., etc. So we need to develop simple things. It was a paper that the fleet manager print and sent to all the driver and put outside the charger. So sometimes the solution is not super digital and super fancy, but that's the reality. The driver of the vehicle is not super energy manager or geek of energy, and also are not the owner. They don't care. They are unemployed. They connect the car. If it's not charged, it's not their problem. He will not do the daily work, etc. So it's also, I would say, internal dynamics that are very, I would say, particular in B2B space.
Yeah, indeed. And maybe I bring in Claire, because Claire, you have this this bundle service, right? So charger plus energy plus software all in one package. Do you find that effective in removing adoption friction? How important is that to your approach?
Yeah, so I did want to add a bit of a comment in addition, I think, in terms of the user experience and potential conflict with grid services. So I think, you know, the points have been very complete already about making it very seamless and making sure that we work within the fleet's initial operational needs. But it's true that sometimes with V2X, we do face conflicts where the fleet just naturally would not be back. It would not be plugged in because they're en route during sort of the peak early evening hours. And so in those cases, and you know, there might be like very high value to seize at like one specific hour or a couple of specific hours, and if they miss it, then there's a big part of the sort of revenue for the month that might be missed. So in those cases, our platform is really designed to try to inform customers so they have that data available, so they know in advance if there's going to be sort of a price surge or a demand response event the next day on the grid, and that there is a big opportunity, so we can tell them how much they could expect to earn from that, and they ultimately can make the decision of whether it's worth adapting their operational patterns or not for it. But I think at least having that information in hand for now is really the first step. And of course, we don't impose any behavioral changes, but I think like early on in this market, we can start at least making the information available in like a very easy to process way. And over time, maybe, you know, grid events will be so valuable, or price surges in electricity markets, that fleets might actually change and make certain decisions based on them.
Yeah, indeed. So the importance of transparency and of clarity and giving the user choice is very, very important, very clear. Maybe before we move on to the slider questions, one last question. Who do you find at this stage are your customers? Who is more likely to adopt these kinds of solutions early, and what are they driven by? Is it like a cost-saving kind of consideration? Is it a environmental consideration that is about, you know, optimizing carbon footprint? So which kinds of fleet managers and businesses at this stage are most likely to come to you for your solutions? Don't know who wants to take the question. Maybe Davide, you are nodding.
Yeah.
So
yeah, okay. So that depends. I would say that there are currently two main customer segments. No, one is the customer or the fleet manager that are electrifying the employer fleet. This is one that have to solve a problem in the company. They need to put charger, they need to install, they need to provide the electrical vehicle. And so at the first stage is not thinking about saving money, or maybe it's not earning money. So it only thinking about solution to speed up the deployment and reduce as much as possible the TCO. When we talk about operative fleet, last mile delivery or something like that, obviously the situation is a little bit different, because sometimes they are a little bit more aware of this revolution in terms of flexibility, so is more keen to listen something additional, no? Above the electrification. This is, I think, the one customer segment that now is growing a lot in general in flexibility, is more keen to listen the story, okay, I would say.
interesting. Yeah, so with that, we move on to your questions that have come through the Slido. So I have one here that is specifically for Quentin. How much more time do you expect will be needed for ISO 15118-20 communication to stabilize and for all EVs to speak the same language? So get your crystal ball out and yeah, give us the timeline for.
The work is ongoing. I think we try with the different projects we have to accelerate the collaboration between the different hardware manufacturers of charger and the car OEM. But of course, we can't work with all the providers at the same time. I would say there is a good signal from the regulation with AFIR for 2027, pushing for the 15.11.8-20, which will probably help to accelerate collaboration and the standardization. So let's say 2 or 3 years.
Let's hope so indeed. The next question I have here is,
Great. Can I just add something, and maybe it's also a question for other panelists' thoughts, but so that regulation applies to the charging equipment, but it is silent on vehicles, right? Do the vehicles actually also have to implement 15.11.8-20? Right. So are we just, having half of the equation here? How's that going to delay maybe the industry, or do we think that the vehicle OEMs are going to follow and have the vehicles also compatible with these chargers immediately? Maybe Quentin, or anyone, I think, Davide.
Obviously, both sides need to talk -20. Okay, that's for sure. Technology speaking. Now, -20 is a protocol. It's a communication protocol. That's obviously the problem is that sometimes there are dialects. So we are in the stage that we need -20, and still we don't have. Now there is the BMW new iX3 announced yesterday that seems to have -20. Mercedes also, the new GLC yesterday, so that seems to have the -20, but still is at the beginning, so it's here story. But then we need the interoperability, so because as I said, there can be dialect at the beginning, for sure in the first year, so and we will need here. And as I agree with the Quentin, B2B story is completely different from B2C story. B2B will never accept a fleet manager to have a charger for one manufacturer. Will never happen this. So let's see. On what I'm seeing since I would say 2-3 years that the -20 was officially published, is still a slow story because automotive industry is not Silicon Valley, I would say. So meaning that we need time. I think that we need years to make it, I would say, interoperable like Bluetooth.
Perfect. One more question from the Slido, and I guess it's a common concern when it comes to V2G. So let's see if we can disperse it a bit. What is the effect of V2G on battery degradation? Is the battery lifetime reduced, and if so, by how much? Do you set limits in daily cycles for the batteries? And so what about the mileage guarantee? So maybe the ones of you that have V2G cases, I don't know who wants to take that question, but feel free to jump if you want to talk.
I can say a few words about this. I mean, this concerns as something that we've seen in the industry from quite some years. So, and also with a lot of back and forth coming from the UNM perspective, like some really being conservative, some other like more playing with the risk of it. But in the end, we need data, and that's the thing. So we need to prove with the cases that we have on the markets what will actually happen on the batteries. And I think it's one of the most discussed topics, and if we go on conference across V2G, I mean, things will change most likely. And also this limit are also very often dictated by internal worries when it comes to the battery lifetime. But this can change really quickly. We need to think that coming from the OEM perspective, the energy word is something quite new still to them. So some OEMs are still like staying a step back into really digging into the energy world. They're starting now experimenting. They need to understand if they want to keep this strategy internally or externally. So that's something that for sure will change. But studies and first evidences are not bringing so much impact on the battery lifetime.
Yeah, in terms of data, just from the projects that we've had in Denmark, we're feeling very reassured from about this issue. It's really kind of becoming a non-issue. So if we look at the data, so there were some studies looking at the battery degradation over sort of 5 to 7 years of operations, and a pretty intensive in the frequency control market. so it's primary reserve, so it's pretty intensive cycling on the battery. And overall, the biggest factor of degradation was calendar aging, so the natural just sort of passing of time and natural degradation of the battery. And the one that was specifically due to this cycling for frequency response markets was adding, so there was sort of 2 to 3% per year was the average degradation just naturally, calendar aging, and there was an additional 0.2% per year of degradation that was due to V2X activity specifically. So that's, really, I think, compelling data. Of course, we need more from more cases, but it's really, there's ways to manage battery health, to factor it into the optimization problem. So we know, high temperatures, high power to energy ratios, so the C rates are things that need to be avoided. But really, from our perspective, in summary, what we're now saying is, charging your vehicle at a very high power charger is much worse for it than doing V2X on a kind of very moderate C rate, especially for corporate fleets. It's really nothing. The power demand from V2X compared to the power demand from traction, just the mobility of the driving, or the power demand, the power supply from high power chargers, those are sort of much more battery intensive activities. And V2X seems so far to have a minimal impact.
On our side, we have quantitative results, if anyone is interested. Basically, in EDF labs, we took EV batteries and we did some V1G and V2G cycles for a month. We accelerated the degradation, of course, because we don't have 10 years in front of us to wait for the results. And the result is something we find in other studies we have seen recently, is that the best profile to lower your battery aging is V1G. Then the second best is V2G, and the worst is natural charging. So V2G actually is the best than just plug and charge, because the worst for your battery is not the number of cycles, is to keep your battery charged at 100% during all the night or all the day. So in V2G, yes, you do additional cycles, but you discharge the battery and you avoid the battery to be charged a lot during all the night. So the two effects are compensating, and depending on the number of cycles and the depth of discharge you do, basically that's better than natural charging. And so the constraints, the agreement, so to do V2G and let's say mass market V2G offer, you need agreements between car manufacturers and operators like us. And in the contract for us to use V2G cars, we have a contract saying you can play in V2G in this range of state of charge. So for instance, Volkswagen, that's public information, you can play between 20% and 80% of battery. And you have a number of cycles or an amount of energy you can charge and discharge each year or for a certain amount of year. So this is typically the kind of constraints we have. And if you respect these constraints, no impact on battery warranty.
Perfect. Maybe we'll do 2 more questions from the Slido, and then we'll slowly wrap up for today. So maybe the next one, maybe about different value streams from EVs, because we've talked entirely about, of course, grid services. But one question that came in is, what is your perspective on the status to use fleets for more than just grid services, for example, for intraday trading? So where do we stand there? Happy for any of you to jump in on a question.
Feasible and happening, no? Meaning, at the end, from a technology side, it's the same thing to do other services, thermomodulation, or same thing in terms of why you are modulating or why you are charging or discharging. That's, I would say, the value of the aggregator, no, in terms of doing that or as energy service provider. It's feasible. Different players, different countries are doing this. Depends obviously on the specific electricity price and country by country, and the spike of the price between and the difference of the price of the hour. So obviously some countries have more interesting spikes, while others are no. So that's depend on that, and that's depend obviously on all the generation side, the structure, how many green generation you have, if there are gas, oil, nuclear, etc. So it's happening, I would say.
On Drive side, basically the example I presented, it's day-ahead energy arbitrage, and because that's old graph, but the new graph, it includes intraday trading. But basically the same thing with a more refreshed data. And then we provided grid services, for instance, FCR in the past, but now we consider that's easier and better to more focus on energy arbitrage. Depending on the use case, of course, depending on the geography and the use case, you can have different value stacking.
Perfect. And we have one more audience question, which is a bit the role of, concerns a bit the role and interaction of, I guess, independent aggregators and larger like electricity suppliers. Are corporates ready to purchase separately their general electricity supply for their business and then separately electricity for EV charging and their flexibility services? So how is that interaction going? Is there any friction, any problems on that side, or is that something that works seamlessly?
Do you mean like different energy contract for the business use and for the EV side, or?
Yes, that's how I understand the question, at least.
Because many times, I mean, if we look at the B2B case, I mean, there's not two different contracts for this. It's one contract covering all the energy needs of the site. What is quite important is that still the business can be independent from the energy supplier to select the aggregator and the access to the market. So this is not something that always needs to go with the energy supplier side, but there are many options that can be explored, especially if, like in B2B side, there might be procurement logics that also push a continuous renegotiation also of the energy contracts. This is not an element that should like block the B2B side then to step into flexibility just because they're worried that they need to change energy provider in a couple of years, for example. So this can still work independently from this perspective.
Perfect. So it comes down again to consumer choice and making sure that the options are available. I think that's a nice note to end this webinar on. Thanks everyone for joining us for this a bit over an hour. You can download now the paper on our website, the position paper on smart and bidirectional corporate fleets, which includes all the case studies mentioned here, so you can have a bit of more of a deep dive or another read of everything you've heard today. And of course, thank you in particular to Laura, Davide, Claire, and Quentin for joining us today. I think your insights have been very, very interesting, have enriched the discussion. We look forward to seeing you for future smartEn webinars. And with that, have a nice day and see you soon.
Thank you very much.
Thank you.
Bye.